Welcome to History Explained, where we illuminate the past to better understand our present. I'm your guide to your daily journey through the past to empower the future. Today is Sunday, June 15, 2025. As we do every Sunday, we're exploring a revolutionary innovation that fundamentally transformed human civilization and launched the modern industrial age. Today, we turn our attention to the steam engine, the mechanical marvel that converted the power of steam into mechanical motion and became the driving force behind the Industrial Revolution. While steam power had been experimented with since ancient times, it was the practical steam engines of the 18th century that revolutionized manufacturing, transportation, and society itself. What makes the steam engine particularly significant is how it freed human production from the limitations of natural power sources like wind, water, and muscle. For the first time in history, people could generate reliable mechanical power anywhere, at any time, transforming not just how goods were made but where people lived and worked. So let's explore this world-changing invention, examining the scientific principles that made it possible, the brilliant engineers who perfected it, its revolutionary applications in industry and transportation, and its profound impact on human society and economic development. The story of the steam engine begins with humanity's ancient fascination with the power of steam. The Greek engineer Hero of Alexandria created a simple steam-powered device called the aeolipile around 50 CE, which used steam jets to rotate a sphere. However, this remained a curiosity rather than a practical power source, as the Greeks lacked the metallurgy and manufacturing precision needed for efficient steam engines. The real development of steam power began in 17th century Europe as engineers sought solutions to practical problems, particularly the challenge of removing water from mines. As mining operations went deeper, flooding became a constant threat that required enormous amounts of human and animal labor to address through traditional pumping methods. Thomas Savery developed the first commercially used steam engine in 1698, called the miner's friend. This device used steam pressure to draw water up from mine shafts, though it was limited by low efficiency and the danger of explosions from high-pressure steam. Despite its limitations, Savery's engine demonstrated steam power's commercial potential. Thomas Newcomen significantly improved steam engine design with his atmospheric engine of 1712. Newcomen's engine used steam to create a vacuum in a cylinder, allowing atmospheric pressure to push a piston down and operate a pump. While still inefficient, converting only about 1% of fuel energy into useful work, Newcomen engines were reliable enough to become widely used in British mines. The breakthrough that launched the Industrial Revolution came from James Watt, a Scottish instrument maker who was asked to repair a model Newcomen engine in 1764. Watt realized that much energy was wasted heating and cooling the cylinder with each stroke, leading him to develop the separate condenser that kept the cylinder hot while condensing steam in a separate chamber. Watt's improvements dramatically increased steam engine efficiency while reducing fuel consumption by about 75%. His engines could also produce rotary motion rather than just the up and down pumping action of earlier designs, making them suitable for powering machinery in factories, mills, and workshops. The partnership between James Watt and entrepreneur Matthew Boulton proved crucial for commercializing improved steam technology. Boulton provided the manufacturing expertise and capital needed to produce steam engines on a large scale, while Watt continued refining the technology and protecting it through patents that prevented competitors from copying their innovations. The Boulton and Watt partnership revolutionized manufacturing by making steam power available to industries previously dependent on water wheels or windmills. Textile factories could now be built anywhere rather than only near rivers, while production could continue regardless of weather conditions or seasonal water levels. Steam power transformed the British textile industry first, enabling the mechanization of spinning and weaving that dramatically increased production while reducing costs. The combination of steam power with innovations like the spinning jenny and power loom created the factory system that would define industrial production for the next 2 centuries. The impact extended beyond textiles as entrepreneurs applied steam power to iron production, pottery making, brewing, and countless other industries. The ability to generate consistent, reliable power anywhere meant that industrial centers could develop based on access to raw materials, labor, and markets rather than being limited to locations with suitable water power. Steam engines also revolutionized mining itself, enabling deeper and more extensive extraction of coal, iron ore, and other materials needed for industrial production. The increased availability of cheap coal provided fuel for more steam engines, creating a positive feedback loop that accelerated industrial development. The application of steam power to transportation created even more dramatic changes in human society. The first successful steamboat, Robert Fulton's Clermont, began regular passenger service on the Hudson River in 1807, demonstrating that steam could overcome river currents and provide reliable water transportation regardless of wind conditions. River steamboats transformed inland commerce, particularly in America, where vast river systems could now support regular, scheduled transportation. The Mississippi River became a highway for agricultural products and manufactured goods, while steamboats opened western territories to settlement and economic development. Ocean-going steamships gradually replaced sailing vessels for passenger and cargo transportation, making international travel more predictable and reliable. The development of screw propellers and iron hulls made steamships faster and more efficient, shrinking the effective size of the world by reducing travel times between continents. However, the most transformative application of steam power was the railroad locomotive. George Stephenson's rocket, built in 1829, demonstrated that steam engines could pull heavy loads at unprecedented speeds, launching the railway age that would reshape geography, economics, and social relations. Railways made possible the rapid, cheap transportation of both goods and people over long distances on land. Raw materials could be brought to factories from hundreds of miles away, while finished products could reach distant markets economically. This integration of regional economies created national and international markets that drove further industrial specialization and economic growth. The social impact of railways was equally profound. People could travel farther and faster than ever before, enabling new forms of social mobility and cultural exchange. Families separated by migration could maintain closer contact, while ideas and innovations spread more rapidly between cities and regions. Railways also standardized time itself, as coordinated train schedules required consistent timekeeping across vast distances. The establishment of standard time zones replaced local solar time, creating the temporal framework that still governs modern life. The steam engine's impact on urbanization was dramatic. Steam-powered factories concentrated workers in industrial cities, creating new patterns of settlement and social organization. Traditional rural communities declined as people moved to industrial centers seeking employment in factories, mines, and transportation. This urbanization created both opportunities and challenges. Cities offered higher wages and more diverse employment than rural areas, but also featured crowded, unsanitary living conditions that bred disease and social problems. The contrast between industrial wealth and working-class poverty became a defining characteristic of the industrial age. Steam power also transformed agriculture through steam-powered threshing machines, tractors, and other equipment that increased productivity while reducing labor requirements. This agricultural mechanization freed workers for industrial employment while producing the food surpluses needed to support growing urban populations. The environmental consequences of steam power were significant and long-lasting. The massive consumption of coal for steam engines increased air pollution and began the large-scale emission of carbon dioxide that would eventually contribute to climate change. Industrial cities became notorious for smoke and soot that darkened buildings and harmed public health. However, steam power also made possible improvements in living standards through increased production of goods, better transportation, and economic opportunities that gradually raised wages and living conditions for many people. The complexity of steam technology's impact illustrates how major innovations create both benefits and costs that societies must navigate. The steam engine continued evolving throughout the 19th century with improvements in efficiency, power, and reliability. High-pressure steam engines increased power output, while compound engines that used steam multiple times improved fuel efficiency. These advances made steam power practical for an ever wider range of applications. The development of steam turbines in the late 19th century provided a more efficient way to convert steam energy into rotary motion, particularly for generating electricity. Steam turbines remain central to most electrical power generation today, whether fueled by coal, nuclear reactors, or other heat sources. The steam engine's legacy extends far beyond its direct applications to encompass the entire industrial transformation it enabled. The factory system, urbanization, modern transportation networks, and mass production all emerged from the economic and social changes that steam power made possible. The engineering principles developed for steam engines also influenced the development of internal combustion engines, which would eventually replace steam power in many transportation applications. However, steam technology continued advancing and remains important today in power generation and industrial processes. The steam engine demonstrates how a single technological innovation can trigger cascading changes throughout society. By solving the practical problem of generating mechanical power reliably and efficiently, steam engines enabled transformations in manufacturing, transportation, urbanization, and social organization that defined the modern world. The lessons from steam engine development remain relevant today as we face new technological revolutions in artificial intelligence, renewable energy, and biotechnology. Like steam power, these innovations will likely have consequences that extend far beyond their immediate applications to reshape how we live, work, and organize society. Thank you for joining us for this exploration of the steam engine and its revolutionary impact on human civilization. Next week, we'll continue our journey through history with another episode of This Day in History, examining the significant events that occurred on June 16 throughout the centuries. If you enjoyed this exploration of the innovation that powered the Industrial Revolution, please like this video, subscribe to our channel, and hit the notification bell so you never miss an episode. We'd love to hear your thoughts. How do you think the steam engine's transformative impact compares to today's technological innovations, and what lessons from the Industrial Revolution seem most relevant for our current age? Let us know in the comments section below. Until next time, I'm your guide for History Explained, where we believe that understanding yesterday is the key to navigating tomorrow.